The introduction to the presentation on testing techniques covers the key aspects of these tools and their significance in the software testing process. Testing techniques support testers in both test analysis, what to test, and test design, how to test. They help in developing a relatively small but sufficient set of test cases systematically. Additionally, testing techniques assist testers in defining test conditions, identifying coverage items, and selecting test data during test analysis and design. Black box test techniques, also known as specification-based techniques, focus on testing the software's functionality without requiring knowledge of its internal implementation. Test cases are derived from the software's specifications, requirements, or externally visible behavior. This approach allows testers to assess whether the software behaves as expected without considering its underlying code structure. There are several black box test techniques, including equivalence partitioning, boundary value analysis, decision table testing, state transition testing, and use case testing. Equivalence partitioning involves dividing input data into partitions or classes that are likely to exhibit similar behavior, ensuring that test cases are representative of each partition. Boundary value analysis focuses on testing the boundaries between these partitions, as defects often occur at the edges of input ranges. Decision table testing is used when multiple conditions determine the outcome of a decision, enabling testers to derive test cases systematically based on all possible combinations of conditions. State transition testing is applicable to systems with distinct states, where test cases are designed to cover transitions between these states. Use case testing, derived from use case specifications, involves testing the system's behavior against various usage scenarios to ensure that it meets user requirements. Black box test techniques are beneficial because they allow for early testing based on requirements and specifications, facilitating test case design before the software's implementation is complete. Additionally, they provide an independent view of the software's functionality, making them suitable for integration testing and acceptance testing. However, they may not uncover defects related to code structure, algorithms, or performance issues, which may require additional testing approaches. White box test techniques, also known as structure-based techniques, involve a thorough analysis of the internal structure and processing of the test object. Unlike black box techniques, white box techniques require an understanding of how the software is designed and implemented. Test cases are developed based on this internal knowledge, allowing testers to assess the system's logic, control flow, and data structures. These techniques are particularly useful for identifying errors or weaknesses in the software's codebase, as they enable testers to target specific paths, conditions, and branches within the code. By examining the internal workings of the software, white box techniques can uncover issues such as logical errors, boundary conditions, and unreachable code segments. However, it's essential to note that white box techniques are heavily reliant on the availability of detailed design and implementation information. Test cases generated using white box techniques may not be as resilient to changes in the software's design or architecture compared to black box techniques. Additionally, white box testing requires a level of technical expertise to effectively analyze and interpret the software's internal structure, making it more challenging to implement without the necessary skills and knowledge. Despite these challenges, white box test techniques play a crucial role in ensuring the thoroughness and completeness of the testing process, ultimately contributing to the overall quality and reliability of the software product. Experience-based test techniques leverage the knowledge and expertise of testers to design and implement test cases. Unlike black box and white box techniques, which rely on specific analysis of the software's behavior or internal structure, experience-based techniques draw upon testers' intuition, past experiences, and domain knowledge to identify potential areas of risk and develop test scenarios. These techniques encompass various approaches, including exploratory testing, error guessing, and checklists. Exploratory testing involves testers actively exploring the software, uncovering defects through ad hoc testing, and refining their test approach based on their findings. Error guessing, on the other hand, relies on testers' intuition and experience to anticipate potential defects based on common patterns, known vulnerabilities, or past issues encountered in similar projects. Checklists provide a structured framework for testers to systematically review the software against predefined criteria or quality attributes. Experience-based test techniques are particularly effective in scenarios where detailed specifications or technical documentation are lacking, such as early stages of development or when dealing with legacy systems. They allow testers to adapt their approach dynamically, responding to emerging issues and changing priorities as they interact with the software. However, experience-based techniques are inherently subjective and can vary depending on individual testers' skills, biases, and familiarity with the application domain. Therefore, while they can uncover defects that may be missed by more formalized techniques, such as black box and white box testing, they should be used judiciously and supplemented with other testing methodologies to ensure comprehensive test coverage and rigor. In conclusion, test techniques play a crucial role in ensuring the effectiveness and efficiency of software testing processes. By employing a variety of test techniques, testers can systematically analyze and design test cases to validate different aspects of the software under test. Black box test techniques focus on testing the software's functionality based on its specifications or requirements, allowing for early testing and independent verification. White box test techniques, on the other hand, delve into the internal structure of the software to uncover defects related to code paths and logic. Experience-based test techniques leverage testers' knowledge and expertise to identify potential defects that may be missed by other techniques. Each test technique has its strengths and limitations, and the choice of technique depends on factors such as the project's requirements, the nature of the software, and the available resources. A balanced approach that combines multiple test techniques can enhance test coverage and improve defect detection rates. Ultimately, the effective application of test techniques contributes to the overall quality of the software, reduces the risk of defects escaping into production, and enhances user satisfaction. Therefore, testers should carefully select and apply appropriate test techniques throughout the software development lifecycle to achieve reliable and robust software products.